Hey everybody, welcome back. OSPF, our third routing protocol. We've done RIP version 2, we've done EAGRP, both distance vector and advanced distance vector. Now we come to OSPF, a link state routing protocol. What does that mean? Well, remember that EAGRP was an advanced distance vector, but it had link state properties by creating those tables. Well, OSPF creates those tables, creates a neighbor table, all right, has a topology table, has a database table. Obviously, every routing protocol has a routing table, okay? But it also, that database makes it special, and the hellos, because once it calculates using the shortest path first algorithm, right, or calculation, because it uses the Dijkstra algorithm, once it converges, it finds out about everybody. Everybody has its adjacencies together. Everybody knows about everybody. Now it keeps neighbor relationships using hellos. Those hellos in OSPF have to be the same with the adjacent router, with the neighbor router, the router that's connected to it. Just so you can understand what I'm saying. With EAGRP, that wasn't the case. That wasn't the case. The hellos could be different, but not here with OSPF. OSPF is very finicky. Very finicky. All right. So yeah, it uses the Dijkstra. You can look that up if you want, so you can learn the physics about it. All right. We use cost instead of metrics or hop counts. OSPF has no limitation on hop counts. All right. It has none, zero. You can have, and is based on areas. So you can have from area zero up to 4.2 billion areas. All right, 4.2 billion areas. And just to give you a little something. All right. Once you get that high in areas, all right, into not even the hundreds, the thousands or the hundreds of thousands, you're not going to say, hey, I'm in area 1,265,368. You're not going to say that. You're going to convert that into an IP address. So you can actually use a IP version 4 address. You do the conversion, you can change the area into that. All right. And that's normally what happens. But it is based on areas. There are not limitations. But you as a network engineer should think, well, the more people I have within this area, the more routers I have within this area, it could be an issue because one link after the convergence, everybody knows about everybody. One link goes down, the shortest path first calculation has to do the whole area again. So a lot of overhead, a lot of CPU usage with OSPF. It also uses a process ID number, but it's a local database number. Local database number. It has nothing to do with anybody else. It's just to maintain that database. All right. And we'll be doing these two types of configurations, which is a single area, which is a contiguous area, just like an autonomous system. Everybody shares the same routing table. And a multi-area, where you all have routers in different areas, or I should say really interfaces in different areas. All right. And we'll talk about definitely and do a lab with designated routers and backup designated routers. Now, like I said before, no limitations on how many routers. But again, you're a network engineer. All right. You have to make smart decisions. You're not going to fill up your VLANs. Let's say you segment your VLANs in your LAN, okay? And because you want to be more efficient so traffic can travel faster. But now all of a sudden you have 200, 300 people in one VLAN. You don't want to do that. Okay? You don't want to do that. It's the same thing with areas. You don't want to fill up your areas where it's like humongous. All right? Hello and dead timers. There you do a show IP OSPF interface, you'll take a look at those timers. They're there. Hello and dead timers. You'll see them. Okay? They have to be the same. So it sounds like a question that you may see on the test. Okay? So hellos and deads in neighboring routers must be the same. Must be the same. And in order to create a neighbor relationship, that has to be the same, or else it won't. Creates the following tables. I told you already, routing, neighbor, and database table. All right, and here's a little bit about OSPF. Don't freak out. These are just abbreviations for those of you that are abbreviation aficionados. But you need to know them because people talk that way. LSDB, link state database. All right, the data structure held by OSPF router for the purpose of storing topology data. That's what the database is for, that router ID, right? Then we have the shortest path first, right? That is the algorithm OSPF uses to analyze the link state database. Link state updates. That's how we get the updates of our neighbors, right? We have the name of the OSPF packet that holds detailed topology information. Link state updates, when we're creating neighbors, say, wait a minute, I don't know about that network. Well, hey, let me send you a link state update, and I'll tell you about that neighbor. LSUs. LSAs, there are many LSAs, and I'll be uploading reference materials so you can take a look at all the different LSAs that there are. There are link state advertisements as you're going through your initialization phase, and we'll talk about that, and you're becoming neighbors. One of the things that will be sent to you are LSAs, the name of class of OSPF data structure that holds topology information. There are different types of LSAs depending if it's coming within your same area, right? Within your OSPF area is an inter area, is an ASBR, right? Exterior. So you have from LSA 1 all the way to LSA 11, all right? So they're all different ones. An area, a contiguous grouping of routers and interface. You're sharing your routing table. And then an ABR, that is an area border router. Area 0 is considered the backbone area. That is the first area that you have to make sure comes up in a real world scenario. In a lab, you can do whatever you want, but area 0 is the backbone area, okay? And everybody must connect to area 0 because area 0 updates everybody else. Real world, all right? So I'll be an area border router connects directly to area 0, all right? Backbone router, okay, boom, any router connected to that. An internal router, a router that has an interface connected to only one area. That makes sense. Internal route and one area, making the router completely internal to that one area. That makes sense. And then we have a DR, a designated router, and a backup designated router. Now, we'll be talking about it, but remember, a designated router and a backup designated router exists only in OSPF. It's an election process. And you'll see that mainly in multi-access networks or broadcast domain type networks or non-broadcast domain networks such as Frame Relay, which is a multi-access network as well. You'll see BDR and DRs or designated routers and backup designated routers in that particular topology if you have it and you're running OSPF. The election process, all right? Now, the election process for those guys is I will choose to be the designated router if I see the highest IP address on any physical interface unless there is a logical or a loopback virtual interface configured. So if it sees a virtual interface, a loopback interface, which is not a real interface, it says, hey, I'm going to choose that. And we'll see that when we do the lab, all right? Or you can manipulate the election, and you'll see how, by changing the priority numbers. Cisco is really, leans more to or likes that you hard code the router ID, that will trump everything. All right. And not lastly, but one of the things that we're going to do is authentication. All right, type 0, obviously, no authentication. Type 1, plain text, we don't want that. So we'll be doing type 2 authentication using message digest. All right, and then here's the configuration. And it's very simple as you go through it. And again, you'll have this. It's basically enabling the authentication on the interface, telling it you're using message digest, and then you create a key, which can be no lower than 8 characters. And then you go into, we'll be doing area authentication. So then you go into router configuration, and you say area authentication or area, whatever area it is. It's going to be a multiple area. So let's say area 2, I think is the one we'll do. We'll see. Area 2, and then we'll do authentication, and then you see message digest. And that's it. The only thing is careful when you're doing this particular lab, because if you do it on the wrong interface or you're in the wrong router, because once you do it on one router, that's going to go down. So when you're doing authentication, and the one doesn't have any authentication, you're not going to talk to each other. All right. Now, requirements to create neighbors. This is important. All right. Must be in the same subnet. Hello. We know this. Must be passive on a connective interface. Okay. Must be in the same area. Yes, we know this. All right. Hello and dead timers. I told you that. The router ID must be unique. Every router ID, and what is a router ID? It identifies the router's name. The router ID is the router's name in an IP address format. That's what the router ID is. Okay, so it will always be unique because everybody has a unique IP address. Must pass neighbor authentication if you have it, and we will, so it has to pass. And K values, that's only in ERGRP, so it has nothing to do with it here. All right. And here how let's break this down. Let's break this down. The first thing is hellos are sent from router 1 to router 2 as an example, right? And this is considered a down state. This is important. This is down state. Then hellos are received in router 2. Hey, I'm in an initialization state. All right, I got a hello from my neighbor. I'm going to reply to him. Now we're in a two-way state. Two-way state. And then routers begin to exchange their link state database information or just database information. And that's called the exchange start state. And then they acknowledge that they're LDBs or LSDBs. That is the loading state. Then they say, hey, give me a link state request. I request your information. He says, okay, let me send you some link state updates. All right, and then one router at a time, sends their updates, what have you. And then once all this happens, it says full state. You'll see full loading done. Great. Now OSPF can begin the shortest path calculation. This is why I'm telling you this, that the processing power is a lot. It's a burden on these particular routers when OSPF. So you got to make sure that when you configure OSPF that you have beefy routers, how much traffic is going through them, and if you are going to have a multi-access network or a broadcast network, that you're going to have a designated router and a backup designated router, that you choose the beefiest router to be the DR. Why is that? Because the DR, everybody updates the DR through the multicast address of 224.0.0.6. And then he will update everybody else through 224.0.0.5. All right, that's the whole reason, because that designated router picks up everything. That's why there's a backup designated router as well. But when you look at those, they'll have those different stages. Once you're doing that, it'll stay, I believe, if I remember correctly, at a two-way state. Those that are not DRs or BDRs stay at a two-way state because they don't complete this process, because they're sending the information to the DR, and as the DR, they will send everybody that information. But this is OSPF. There's a lot to OSPF. We'll be doing a couple of labs in here, all right? And you'll get very friendly with OSPF. It's not that difficult. Remember this, the CCNA. We'll be doing basic OSPF. We'll look at the DR, BDR. We'll do multiple area OSPF. So we'll do authentication. So no big deal. It'll be fun. It'll be easy. So let's get started. All righty. Look what I have here. GNS3. Ha ha ha. We're going to practice a little bit with GNS3 because we are going to get into very intricate configurations when we get to BGP and NHRP and all that good stuff. All right, so we got BGP here, but just pay attention to the purple area, the highlighted area, those three routers right there, routers 1, 2, and 3. All we're going to do, the IP addresses are there. All we're going to do is configure these interfaces right here with OSPF. That is it. All right, and take a look at a couple things. So just to get a little warm up, you get familiar with OSPF, okay? So enough talking with me, and let's get down into the lab. All right, welcome back, everyone. We're here in the router OSPF lab, and as you can plainly see, it is no longer the packet tracer. We're now using GNS3 because we are moving into more advanced configurations within OSPF and with other routing protocols and designs that we're going to do. All right, not to mention when we start getting into BGP and all that, this is the simulator that we're going to use. All right, so the first thing is it's just a basic configuration to get to know OSPF. We have the 4 network and the 8 network, 3 routers. Very simple, very simple. All right, so I already have it open. Let's go to router 1 here, and as you can see, I was playing around already in there. If you don't know which interfaces actually have the IP address, one of the things that you could do is show IP int brief, and if you spell brief correctly, it should work just fine. There you go. So F00, you can see that's your 10.1.1.5, and there's a reason why you need to know that. And you can also type show protocols actually, and what you can see is also the subnet mask, because with OSPF we're going to use wildcard mask. So let's go ahead and start. We need to be in global configuration. And then we go router, OSPF, and then a number. Now, so you can see I'll do a question mark, and there it is. We have from 1 to 65,535. And we're just going to pick 1. It's a local number. It's to maintain that database that OSPF creates. So we really, it doesn't really matter. It's not going to go to any other router whatsoever. All right, so now we do the networks that we're attached. And we're really only attached to one network, net, and that's the 10.1.1.4, and then 0003. That's why I needed to know the subnet mask, so I know what wildcard mask to put. And we're just going to use area 0, which is considered the backbone area. And in reality, that's what you would do. That's the first area in a real world scenario that you will bring up, because it is the backbone area. Everything needs to be connected to area 0, directly or indirectly. All right, so we're going to do WR right here, which you can do. You have to do this. You have to go back to privilege mode, and then you can go ahead and do a copy run start. So now we're going to go ahead and go to router 2. And remember our topology that we have right here. Okay, so we just did this interface. Now we're in router 2. We have to do 2 interfaces, the F10 and the F00. And again, if you are, you don't know which interfaces have the IP address or the subnet mask, show IP or show protocols, I should say. And you'll see they'll tell you, okay, you have the 10.1.1.9 and the 10.1.1.6, all right, which is really the 10.1.1.4 and the 10.1.1.8 network. All right, so let's go to global configuration, config T, and then we go router, OSPF, and 1. It could be the same one or different ones. It really doesn't matter. And then net, short for network, 10.1.1.4.0.0.0.3, area 0. Now be careful when you're doing this, because this is the neighbors attached. You can see, boom, automatically you created a neighbor relationship. And when you see full loading done, that means, hey, everything's good to go. All right, now we're going to do the other network. I'm just going to up arrow, and I'm just going to change it from 4 to 8. And we're done there. Let's do WR. All right. And let's go to router 3. And again, I'm going to do show protocols just to see what, and it's the 10.1.1.10, so I'm in the 10.1.1.8 with a 30 mask. All right, cool. Config T. Just want to show you commands that if you don't know the IP address or the network, what you can type so you can see where you're at and what's configured. Besides doing a show start. In real production router, you're not going to do a show start. All right, unless it's a very small company. All right, so we're going to do a router. Spelling counts. OSPF 1. Network. And then 10.1.1.8 is the 8 network. 0.0.0.3. And then we got area 0. All right, then we do WR. And you can see we have full loading done. So Control Z, right from right here, let's do a show IP route. And I'm learning about the 10.1.1.4 network. You can see right here from OSPF. And you can see the administrative distance of OSPF, which is 110. And that particular network is 2 hops away. Very similar to the other routing protocols we were doing, just a different configuration. I'm learning it via that particular 10.1.1.9 on my F10 interface. Now, just to completely verify, we're going to do a ping right from here, 10.1.1.5, right? And I get a successful ping all the way across. All right, so you know that you have connectivity, and that's one of the things that you want to do when you're doing OSPF or anything that deals where you have to verify connectivity or fix your routing protocol and IP address. Make sure you do have connectivity, whether you're doing a trace route or a ping or a telnet, whatever the case may be, before you click that next button. All right, so this is the very basics of OSPF and how to configure it within a very simple design. I'll see you outside the lab. All right, that wasn't that difficult, was it? Very easy. Always gotta be careful. Remember, it's a 30, so we're using wildcard mask. No need for no auto summary. There's a link state routing protocol. There is no default summarization. So we put the complete network, and then we use a wildcard mask, and then the area that we want these interfaces to participate in, which in this case is area 0. And once we do, boom, you see an O, we can ping, back and forth, not a problem, right? Very easy to do. OSPF, basic configuration. I'll see you in the next. All right. Yes, we're in the packet tracer because it's the quickest way to show you this. Okay. What we're going to talk about now is the designated router and backup designated router. Okay. It is important you understand what they are, how it's elected, and how to look for it. All right. And where does it occur? This election process. Let's do the easy stuff first. That's why we have these two right here. You have the identical same two routers with just the difference. This is an Ethernet cable and this is a serial cable. All right. So let's take a look at the serial cable. Let's see who's the designated router and backup designated router is. So we're going to go inside this router right here, router 4. Let's put it on this side. All right. No, we don't want that. We want this. All right. And then we're going to do enable. Oh, we can do it from right here. We can do a show IP interface. No, show IP OSPF interface S0/0/0. Show IP OSPF interface. OSPF. All right. And then we're going to look to see who the router is. It says here, the internet address is 10.1.1.30. And the router ID is 11111. What is that? The type of network it is point to point. And there is no designated router. And there is no backup router. Oh, well then, I don't think OSPF must be configured on here. Let's see. Show protocols. Okay, so packet tracer versus GNS3. Show start. So we indeed have OSPF configured, but yet we're getting that there is no designated router, no backup router, and backup designated router. Why? Because the priority is set to 0 by default on serial interfaces. So since we have a priority of 0 on serial interfaces, you will not have a backup or designated router, okay? Even though it's on a point-to-point, because that's what your book says. On a point-to-point network using OSPF, the backup designated router will be the IP address with the highest IP address on any physical interface, unless there's a loopback configured. And indeed, ladies and gentlemen, we do have a loopback configured, which is a virtual interface used for testing or election process. And as you can see, that is the router ID. So a DR or BDR does not exist, but a 1.1.1, which is on this router right here, and we'll verify it by doing a show IP in brief. All right, you can see that this is indeed a loopback 1.1.1.1. So therefore, the router ID for this one is this. But if you go to this particular router and you do the same exact command, show IP OSPF interface S0/0/0, and you see that the 222, the loopback address, is taking precedence over the physical interface. And that's what it says in the book. In an election process, which here you see there is no designated router or backup designated router, but it is choosing to use the loopback interface as its router ID because it will prefer to use that instead of the highest IP address on any physical interface. Why is that? Because loopback addresses do not go down. They're virtual interfaces. Where physical IP addresses, because they're on physical interfaces, or not physical IP addresses, but IP addresses on physical interfaces, those interfaces may go up and down, up and down. You may have a flapping interface. Therefore, that process will always be happening. Always, that election will always take place. So take notes. This is what I'm trying to show you. That on serial interfaces, there is no election process for designated or backup designated routers because the priority is 0. Also to take note that the loopback interface is what's becoming the router ID because it is the preferred, right? Because it's a virtual interface. All right, so let's take a look. Let's close this. Let's close this. And whoa, what a scary background. All right, and let's go ahead and open up this guy right here, if it wants to. All right, there we go. All right, so now we're doing on a fast Ethernet interface. You see full loading done, so you know OSPF is already configured. We're gonna do enable. We're gonna do show IP OSPF interface F0/0. Enter. And lo and behold, what does it say? Designated router 33333. Backup designated router 44444. So there is an election process in an Ethernet network. Why is that? Well, let's dispel the mystery. Because the priority is set to 1. Because priorities can be set from 0 to 255. 0 means do not make an election. You will not take part in an election. 1 is the default, all right, for fast Ethernet. So you will participate in an election, and based on the rules of the election, I will choose it should be the highest IP address, should be the designated router, and the lowest IP address should be the backup designated router. The reason that this happens is in the order of configuration. But regardless, it's choosing the loopback interface over the IP address on the physical interface. What are you taking note here? That the priority on an Ethernet connection, point to point or whatever, it's going to have a priority of 1. So since you have a priority of 1, it's going to say, hey, whatever interfaces are on here, or if they're Ethernet, they're going to take part in the election process. All right? And that you will go ahead and get a backup designated router and a designated router, okay? 33333, whatever the case may be. All right? Or the physical interface, but not on a serial point to point. Keep that in mind. And you can see that the type of network here is broadcast. Where up here, it was point to point. Here is broadcast. All right. So now you know the difference between serials and on a point-to-point connection, which indeed will have an election. All right. So what we're going to do is go to our other example over here. We have a multi-access environment. A multi-access environment. So what we're going to do is we're going to configure, and we're going to do it quickly. We're not going to waste any time. Notepad. All right, we're going to say router OSPF1 network 192.168.1.0. I know I got 1.1 there. 000.255 area 0. And the loopback here is 3. Okay, I believe it's 3. Should have chosen 3. Let's see. Always verify. Always verify. Don't leave anything to guess because you're taking a certification. Show IP in brief. And you're not going to have, yeah, it's 1.1.1. You see that? I would have made a mistake. Huge mistake. All right. Here we go. And then you go net 1.1.1.1. 0000 wildcard mask area 0. That is your loopback interface. So we'll go ahead and copy this. Control C. We'll go to our router. We'll go to config T. And we'll just paste. All right, hit enter. Do WR. That is awesome. Now we're going to come over here. Now let's see what I chose for a loopback over here. Show IP in brief. I chose 22222. So I'm assuming this is 2223, 4444. Okay, so let's go to Notepad. And all we need to change, because this network stays the same, so the only thing that's going to change is this right here to 2.2.2.2. And let's create a couple enters here. Well, let's do this. Do so type less. Do WR. And people will hate you for doing this, but hey, this is what's called efficiency. Control C. Go to the router, global configuration, and then just paste. Done deal. Awesome. We should get a loading done, but we'll see how long that takes. All right, then we're going to go to this router right here. We already know that's going to be 33333, but we're going to verify it anyway. 3.3.3.3, because in a multi-access environment, you will have one designated router and one backup designated router. So let's go ahead and copy that. Control C, but I'm going to verify. Even though I've copied it, I'm going to verify before I paste it. Always verify. Show IP in brief. And it is indeed 3.3.3.3. I'm going to do config T, and now I'm going to paste. All right. Now we're going to go to our last router. Let's just verify since we're there already. Let's do a show IP in brief. And this is 44444. Awesome. So all we need to do is change this configuration right here, which is our loopback interface, our virtual interface, used for testing purposes, or for this case, for election process. So this is going to be the router ID, Control C. And then we go into the router, go to global configuration. All right, and then we just paste. All right, cool. So that's done. Show IP route. And lo and behold, it's not working. Isn't that great? Well, this is all part of IT, is it not? Yep, there we go. OSPF is not the quickest. BGP is slower than OSPF, but hey, we make do with what we have, right? That's one of the things you learn in IT is patience, patience, patience. There it is. We're learning about the 1, we're learning about the 2, we're learning about the 3 because we're the 4. Okay, so OSPF is working, but what we need to know, hey, who is the designated router and the backup designated router on a multi-access network? Well, show IP OSPF F0 or interface F0/0 and you hit enter. So what we have here is, as you can see, there's our priority of 1, so there will be an election, and we have a broadcast type of network because it is a multi-access network. We're all connected to one switch, one broadcast domain. And look at this. It's using the loopback addresses. Now, the router ID is 44444. But look how weird. The designated router is 1111. And the backup designated router is 2222. Well, why is that? Well, that is because we configured this first and then we configured this. It said, hey, I'm the only one on this network, so I'm the designated router. And then this guy came up and said, hey, I'm the second guy here, so I must be the backup designated router. And as we went along, everybody just accepted that as the fact. But we're going to change that. We're going to cheat. You would never do this in a real world environment. You actually, there's things you can do to say, hey, you're going to be the designated router, and I'll show you now. But what we're going to do, we're going to just do something that you would never do in a production network unless you're in, maintenance time or something like that. We're going to reload the switch. Well, what happens when you reload the switch? Well, everything turns off. And if everything turns off, then everything recalculates, right? It's like everything went down, everything needs to come back up. Now, other things, the next thing that we're going to do, which really is the best way, Cisco recommends really to hard code the router ID, all right? But if you want to make sure who's going to be your designated router, which is usually your router ID, but because I'll trump everything, I like to use the priority number, and that's what we're going to use next. We're going to use the priority number of 255 that states, hey, I am the designated router. Any number below me will be the backup designated router. So we're going to designate a particular router as a designated router by changing the priority on the interface. And then we'll put one for 255, we'll do one for 254, we'll do the extremes, and you'll see how that would change immediately. All right, so let's go back again to our famous router over here. Let's see, we got the full loading done. Let's make sure we got show IP OSPF interface F0/0. Let's see what happened. And voila. Now we're using, as you can see, the router ID is 4444 and the designated router ID is 4444. So that's why the router ID, if you hard code it, if you put it in or the OSPF configuration, that will make it the designated router. But we're going to use priority numbers. So you can see that it's still choosing the loopback interfaces to go ahead and use them as your backup or designated. Now remember, the designated router will use a 224.006 where it sends updates from. Everybody else will use the 224.005 to send its information from, because OSPF does have two multicast addresses that it uses. Okay, so based on the rule that use the highest IP address on any physical interface unless there is a loopback address assigned, then you will use that, because virtual interfaces do not go down. Therefore, you will not get any flapping interface when that's concerned. But what we're going to do is that we're going to go back and we'll make this router here the designated router, and we'll make this router here the backup designated router. So let's go ahead and go into its interface, right? The interface F00. So we're going to escape out of here or exit. We're going to interface F0/0, and we're going to say IP OSPF priority, and we're going to do 255. That's going to be the designated router. Do WR. And we're going to go to the other router, Fast Ethernet 00. Okay, because that's just the way we are. That's the way we want it to work in our network because of our design. Whatever the case may be, beefy router, who knows? Because remember, the reason for the designated router, everybody sends to the designated router, and then the designated router updates everybody else. That's the whole point. All right, so we're going to go to interface F0/0, and then we're going to go IP OSPF priority. I tab a lot, so I turn to do a lot of misspelling. Priority 254, one less. Do WR. Alrighty. And let's see if it changed automatically. Let's go back to our router over here. Or we have to do a little trick again. I'm just going to up arrow, really. Up arrow, there we go. Now it's still telling me the same thing, so let's do a little dirty trick that we normally wouldn't do. Alright, this is the switch. And we're going to reload. Danger, Will Robinson. You don't want to do that in a production network, but this is a lab environment. And the whole point that I'm trying to show you is that you do not, or you can manipulate the election. You can manipulate the election. Serials, no elections, because priority is 0. Fast Ethernet, there's an election, because it's Ethernet. So the priority is 1. And then you have an election. Here, and also the order of how you configure will make that one designated or backup designated. And we can then go into the interface and say, hey, we want that particular router to be the designated router, and we want the other router to be the backup designated router. So everything is green again. Let's go in here. Let's make sure we have full connectivity. Show IP route. Not yet. OSPF is taking a sweet time. We just keep doing this. There we go. Until it starts loading everything up and still has not. Come on. Let's wait. It sees its own loop back. Let's go over here. Let's see what this router's got. See full loading done over here. Drive your route. It's got some stuff over there. Okay. Let's go over here. Let's try it again. Swipe your route. There we go. We got the 1, the 3. The 2 is the one that's taking quite a bit of time to show up. Come on, 2. Swipe your route. 2 is being stubborn. All right, swipe your route. Okay. Let's go back to this guy. Still is not getting the 2. But let's see. Let's go to this guy. And let's do a show IP OSPF interface F0/0. Let's see if anything's changed. Let's maximize the screen. And what are we looking for? Is now, oh, look at that, router ID 2222, or the designated router 2222, and the other one is 1.1.1. Why? Because we changed the priority. We changed the priority. And the 1.1.1, we know it's this one right here. Okay, so we do a show IP interface, show IP OSPF interface F0/0, and you'll see that you'll have your designated or backup designated router is 1.1.1, and then your designated router is 2.2.2. And because of the priority that we changed, all right, that's all it takes. I'll see you in the next. All right, we did single area OSPF. Now we're going to do multiple area OSPF. But like I told you at the beginning, the first area that we're going to start is area 0. That's the one we need to bring up first. Once area 0 is brought up, then we can bring up all the other areas. And you see what's going to happen. I'll see you inside the lab. All right, here we are in our lab once more. But now the lab looks a little slightly different. We added 2 more routers. That means 2 more networks were added. And we're still going to do OSPF, but as you can see, we're going to be doing multiple area OSPF. You have area 0. These 2 interfaces will participate in area 0, just as these 2 interfaces will also. And then these 2 interfaces here are going to be in area 1, and these 2 are going to be in area 1. And since, well, what happens at that point is that this becomes an ABR, an autonomous border router. Okay, and but again, you can be directly connected to area 0 or indirectly connected to area 0. Anything further than this router right here, you will need something called and I'll show you when I get in there because the name escapes me, but so you can go ahead and be able to tell it, hey, I exist, I need the updates as well. All right, so let's go ahead and start configuring. Now, the first thing you need to configure is area 0. That's the first area that needs to come up. So we're going to go to router 2. We know the both networks, which is the 10.1.1.4 and the 10.1.8. So let's go to router 2. And I already took out the previous configuration as far as the routing protocol. All right, so router OSPF 1 network 10.1.1.4, 0003, area 0. And then we're going to up arrow. And then we're going to change this to 8. All right, those are 2 networks that I am currently attached to. I'm going to do WR to copy the information. Obviously, you can't do that. Now we go back to our lab here. We're going to go now to router 1. Now, router 1 is in 2 areas. The F00 is in area 0. The F10 is in area 1. Okay, so let's go to router 1. Okay, so we go conf t router. I can't spell router. Router OSPF 1 network 10.1.1.4. This is the one that's in area 0. So we put it that way. And now, you know, you're going to get an adjacency. So just wait for it. Wait for it. All right, it's taking a sweet time. Oh, there it is. Okay, so I'm going to up arrow again. I just wanted for it to in the middle of my typing. And then now I got to change the area, which is area 1. And then it's going to be 0. Because that's the network that I placed there. The 0 network. The 10.1.1.0 network. But it's in area 1. And I'm going to do WR there. Okay. All right. So now that we got that done, let's go ahead and let's do, let's do router 3, where the F10 is in the 0 area and the F00 it's in area 2. Okay. So the 8 network is in area 0 and the 12 network is in area 2. So let's go to router 3, config T or conf T, router, OSPF, 1, network, 10.1.1.8, 0003, area 0, and we're going to get an adjacency. Oh, I got it. They're quicker than the one before. And then the next network is in area 2, but it's the 12. All right, do WR. And if we were to look at our routing table at this point, do a show IP route, you see that now we have something called an inter-area, because it's learning about the 10.1.1.0 from router 1, or from this particular router. Let me see if it's router 1. From router 1, it's learning about that particular interface, the F10 interface. So we have an inter-area router because it's going from the area border router. It's not an ASBR, which is an autonomous system border router, which would be another routing protocol or the internet. That's where the ASBRs would be. This would be an ABR. So it's already learning about that particular area. Okay, as you can see, it's 3 hops away, the 10.1.1.0. That's the only one it knows about at this point. But still, we're not done, right? We got 2 routers beneath us. And if you look at it, we have router 4 and router 5. They already have their IP addresses. All we need to put is their interface in that particular area. So let's go to router 4. Now, if we go to router 4, we're going to do a show IP route. You can see that he doesn't know about anything. There's no OSPF configured whatsoever. All right, so config T, router, OSPF, 1, network, or net, 10.1.1.0, that's the network that's in, and then you have 0003, and that is area 1. Okay, and we should get an adjacency here. There we go, do WR. And let's go now to the other router, which is router 5. He's in the 12 network, that F10 interface. So let's go ahead and put him in area 2. So let's go to router 5. And go conf T, router, OSPF, 1, network, 10.1.1.12, 0003, area 2. Enter. Do WR, and you see we're getting full loading done, which is a good thing. So now if I were to look at the routing table of router 5, let's clear all the gibberish off the screen. Show IP int brief. Brief. Show IP route. There you go. Okay, show IP route. Come on, fingers, work for me. And there you go. It's learning about all the areas, the 10.1.1.4 and the 10.1.1.0. All right, obviously it's learning it through our ABR, all right, which is 10.1.1.13 on our particular interface. Okay, and the same thing goes with this network right here. We're learning it from the same ABR on our particular interface. And just to prove that we have connectivity, we're going to ping 10.1.1.5, or 10.1.1.1, I should say. And we do have full connectivity. But now we have inter-area OSPF. Anything beyond that, if you were to add routers beyond that ABR, beyond router 5, if I go to router, config T, router OSPF 1, this is a question mark here, okay? There will be something that you need to change, okay? It will be starting with the area command. You say area, and the area that you're traversing, let's say it will be area, in this case, 2, and then you would put the, the virtual link, okay? And it will be the router ID number. I'll question mark that. It will be, or an IP address, it will be the IP address or router ID, which would be the router ID of the router you're connected to, your neighbor's router ID in the form of an IP address. That's if you go beyond router 5 or router 6. But since these routers are connected to directly to the area border router, there's no need for that. They learned it automatically because they're connected to it, like if they're directly connected to it, right? Through the ABR. So they're learning everything about Area 0 and of course Area 1 and Area 2 and all that because they're directly connected to these ABRs. Anything beyond that, you need to use the area command within router configuration, router OSPF configuration, and use what's called the virtual link using your neighbor's router ID in the form of an IP address. And how would you find that? How would you find that? Let's go to router 1. Let's say you need to know the router ID of that particular router. How would you see that? Well, you can do a show IP OSPF database, and you would see the router ID right here. It's 10115. So that router ID will be your virtual link. That will be your virtual link that you would put on that particular router. And as you can see, that this router, by doing the show IP OSPF database, is running area 0 and area 1 as well. And it gives you the IP addresses and really that's all you really need to know, the age of how long it's learned, because these could be questions that can come up. So the show IP OSPF database, it's a very important command. It will show you not only your router ID, but what areas is your router connected to and the age, how long has it learned that particular route. But again, very simple. This is a very simplistic multiple area OSPF. I don't think we're going to get more than that. But we'll continue configuring as we go, and we'll see what we get. I'll see you outside the lab. All right. That was not bad at all. Pretty simple. All right. Since we're connected, remember now this becomes the ABR, the area border router, which is connected to the backbone. So once we configured this particular area, it already knew about all the other areas. Okay. If you go beyond that, like I said, you will need to go inside router OSPF 1, do area, whatever area you need to traverse, virtual link, and then your neighbor's router ID. That will be the, if you had another router, but we don't. This is a very simple multiple area OSPF. Anything beyond that, then you need to do your virtual links. But I doubt that for the CCNA, they're going to go ahead and do that. Just be aware with multiple area. Remember, this router is in 2 areas. This interface is in area 0. This interface is in area 1. And now what did that create? What do we see in our routing table? Inter-area routers, because they're within our area, okay? So when the same thing happened over here, we had inter-area routes that we're learning from, okay? And those LSAs will change. Those LSAs will change from inter-area, or if they're coming from an exterior source, okay? Depending if they're type 1 or type 2, but again, going outside the scope of the CCNA, okay? But this is your multiple area OSPF. Very simple. See you in the next. All right. Same lab. There's our multiple area lab. But what we're going to do is, between these 2 routers right here, we're going to do some authentication. All right? We're going to do some area authentication. So we got to make sure, because this is where I tell you, you got to be careful. Because as soon as you put authentication on one interface, it's going to go down. It's going to go down because he's not doing authentication. And that was one of the things. It was optional, but if you're using authentication, it's got to be on both. If not, one's not going to become, they're not going to become neighbors because, hey, you don't have my password. I don't know you. So we got to be careful with that. You'll see that happen in the lab. So without further ado, in the lab. Alrighty, welcome back. Now, this is our same multi-area OSPF. And what we're going to do, and we're just going to do it on 2 routers, not to make it complex. The concept of this is how to enable area IP authentication on OSPF. Okay? So what we're going to do is we're going to pick two routers. We're going to pick router 5 and router 3. And they're going to be authenticating to each other, all right, through area authentication. So these are the only two. Obviously, if you want to encrypt all the commands, then you will go all the way around. This will only affect area 2. So let's go ahead. First, we want to see we have connectivity across, and I believe we do. Let's go. No, not there. Where my computer? There we go. This is router 5. Okay, what's this thing do? Playing with me? Okay. And I think I was checking already, but we're going to check again. Always check. Show IP route. There's our networks. Let's ping 10.1.1.1, which is all the way up to the other side. If I type it correctly, it would work. And there we go. So we have success. We have connectivity. Now, the interface that we're going to do it in, we're going to do it on router 5's F10 interface. F10 interface on router 5. So let's go to router 5, which we're in. ISO config T. Interface F. I just said it a million times and I just forgot. Do show IP in brief. But hey, that's me. It's the age, ladies and gentlemen. It's the age. Okay, F10. Here we go. As you know, with an IP address. Interface F1/0, not O, 0. All right. Now we're going to do authentication. IP OSPF authentication. That turns it on. That enables it. All right. Then we're going to do IP OSPF authentication message digest. But we need a key, right? So these guys can talk to each other. IP OSPF authentication. And yes, I'm tabbing my way through key. It has to be at least 8 characters. So we're going to type in Superman. All right. Then we go to the area router OSPF 1. OSPF 1. And then we do area 2. And you can see since I'm putting authentication already, they're like, hey, our update, our hellos said that there's no authentication. So the dead time expired. Area 2, authentication, message digest. As you can see, you question mark it. There's nothing else you got to do there. Do WR. All right, do WR. And if that's the case, if a dead timer expired, something must have happened to our routing table. Show IP, not router, but route. Okay, we have no more routes. We don't know what's going on. So we got to go to the router that's above us, which is router 3. Or F00. Let's see if I remember. F00 on router 3. I'll say it again. F00. So I don't forget. Config T int F0/0. We're going to enable authentication. IP OSPF authentication. Let me use all barrel hyphen. I will use message digest. I'm sorry. Use message digest first. Message digest, and then we'll do IP OSPF authentication. And you see it loaded already. Key is going to be Superman. All right, I spelled it wrong. IP OSPF authentic. That's why tab. Tab is your friend. Key Superman. It's telling you there's going to be truncated because I put Superman. But I'm going to up arrow again, get rid of the T, and put that in there. Then we're going to go into the area router OSPF 1. Area 2 authentication message digest. Do WR. Now, you can see I have a little spelling difficulty up here, but it doesn't matter. The first thing you want to do is under the interface that's facing router 5, you want to enable authentication. Then you want to do the message digest. Then you want to put in the key, which is 8 characters Superman. I put Superman. So it gave me a warning. It says, hey, we're going to be truncated that to Superman, to 8 characters. So I just got rid of Superman, and put Superman. All right, but it looks like we have some full loading done. Something's going on here. let's take a look at our starts. We can see how this looks like if you're going through it. You see that your interface, you have IP OSPF Authentication Message Digest, IP OSPF Authentication Key Superman, and if you look at your routing protocol, you have Area 2 Authentication Message Digest. Okay? Now, let's go back to, we're going to do it from right here. Let's go back to router 5. Remember router 5 lost all? You saw that? We had no areas. We have nothing. We only connected to ourselves. We had no idea we're alone in the world. So let's do a do show IP route. And now we're back. Now we know all the areas. Let's do a do ping 10.1.1.1, 10.1.1.1, dot one. And we can begin again. But this time, between router 5 and router 3, we have the encryption message digest going on. So it's somewhat secure. So the same thing you can do to each link on the network. Let's bring our network back up. So right now we have encryption here between these two routers. We can do the same thing between these two routers, between these two routers, and between these two routers. Essentially, that's what you want to do. But that's how you would do it. Oh, well, that's one of the ways you would do it. All right, there's a million ways to secure your network, access list and radius servers and all sorts of stuff, TACACS, all those different things, but just basic authentication. Remember, this is the CCNA. All right, so for authentication, this is the most basic way that you can do it, so the routers can say, hey, well, let's use the same key. Let's talk to each other to make sure no rogue routers come in. All right, well, there you go. That's IP OSPF area authentication. I'll see you outside the lab. Not that difficult, right? We're going inside the interface, IP OSPF authentication, that enables it. IP authentication, message digest, all right? IP authentication, hyphen key, and then the 8-character key that we're going to use since we're using message digest, right? If you did like I did, I put T at the end, so it tells you we're going to truncate it, we're going to make it into 8 characters, so I just put Superman instead of Superman. All right, so that was the only thing. And then, but you saw that the interface went down. We lost the neighbor relationship until we actually configured up. Oh, then we went inside the area, of course, router OSPF 1, area 2, authentication, message digest. You know, but that's all you got to do. And then, boom, once we did it to both, we got back our routing. We're able to ping back and forth. Just remember, the keys need to be the same. They are case sensitive, all right? You choose the type of authentication you want to use, okay? But definitely be careful and remember the interfaces that you're in so you can go ahead, documentation, because it's not a simulator, real router. So document your work and which interfaces you actually did the authentication for your OSPF. Well, that's it. That's your OSPF authentication. See you in the next. We've made it to the summary of OSPF. So what do we talk about? Well, saw that big old presentation that we said everything about OSPF, right? It was a link state routing protocol. It has hello and dead timers. There's no limitations, right? You can have, because it's based on areas. You have from 0 to 4.2 billion areas. You have the process ID number, which is for local database, okay? When there is no default summarization, so we use wildcard mask plus the area that we're using, okay? And we did a multi-area OSPF as well. We did configured both, all right? We also did OSPF authentication. We rounded it off with that. Very simple to do. But there's a lot to OSPF, okay, when you are configuring, especially when we do the DR and BDR. We saw 3 examples of that, all right? But OSPF definitely, since you can do multiple areas, you can do, single area if you want, as big as you want. Not recommended to do that. But hey, you know what I mean? It all depends on what you want to do. Area 0 is the backbone area. We saw some of the abbreviations like link state database, link state updates, link state advertisements, right? The DR, designated router, backup designated routers, all right? All that, all right? There's a lot to OSPF. So go through these lectures, nice and easy to understand the commands, understand what's going on, especially when creating the neighbor relationship, when we have to have the same subnet, your hellos need to be the same, okay? You need to be in the same area. Neighbor relationships, neighbors, okay? Meaning the interfaces. Because when we actually when we're doing the network, we're actually telling, hey, this is the interface that's going to be part of this area. So if we have a router like an ABR, an aerial border router, its interfaces are in 2 different areas. But you see that one of the interfaces is facing another interface that's part of that area, and this interface over here is part of this area. So your interfaces that face whichever router need to be in the same area, same subnet, same hellos. All right, there is no K values in OSPF, but that information is there for you to peruse at your own leisure. And I will be updating some more terminology that will help you also understand what's going on. All right, so that's OSPF in a nutshell. We went through the most important parts of OSPF. I will see you in the next one.